All right, let's try this again. So let me just tell you about my morning. So I wake up about 6:50 ish. Get up, walk the dog, uh, get dressed, get almost to school. Realize I didn't bring my computer. Turn around, go get my computer, come back to school, put the finishing touches on some of our slideshows and our assignments. And then go post them, go to record, kind of knock that out real quick. I record like a 30-minute video in my American history class, and then I realized that the software or this video program crashed. Had to restart my computer, had to update, did this video, and then it crashed again. And so we're going to try this well, I still got a couple videos to go. We're going to try this again. All right, so today we're looking at Aristotelian logic. Now, past couple days we've been talking about logic, and I appreciate you guys' willingness to work on some of the logic practices that I've given you, especially those Sudokus yesterday. I kind of made an error, and I know some of you spent a little bit more time than you wanted to trying to figure out that second puzzle, but I appreciate your willingness to keep trying. I really appreciate that. If you look, I mean, the hardest things in life is to commit to doing something and then stick with it. And a lot of you committed to starting it, you worked on it, you still couldn't figure it out, you were continuing to try, and then I realized I made a mistake. But if you can commit yourself to something and stick with it, that's life. That's how you accomplish anything. All right. Well, with that being said, let's review a little bit what we've talked about with logic so far. So I'm gonna move my face. There we go. All right. So, what is the purpose of logic? The purpose of logic is to learn. It is from Aristotle. It is the tool, logic being the tool that we use to come to know anything. That doesn't mean that logic is all there is and that everything that is of value has to be logical, because sometimes, I mean, think about it. Like, would people take risks if they were only thinking logically all the time? No, this is, again, based in math. This is based in mathematics. You're talking about odds, probabilities, talking about observation statistics. So there is more to philosophy than just logic, and there is more to life than just thinking logically. Though, many of us would probably do better if we thought a little bit more along those lines. So what two kinds of logic exist in Aristotelian logic? Well, we talked about that previously, the formal and informal logic, which takes us down to how we use that logic. Formal logic we use by deductive reasoning, which is taking a generalized principle, coming to a specific conclusion. While with informal logic, we're looking at the reverse, through inductive reasoning, specific instance to a generalized conclusion. What are these types of arguments called? These types of arguments that you guys actually created 2 days ago are called syllogisms. And in logic, in the field of logic, this is probably what Aristotle is most known for, those propositions, those arguments that we were talking about 2 days ago. So let's continue and let's look a little bit more into what Aristotle has for us today. Oh, I need to move my face again. There we go. All right, so this right here is Aristotle. And he developed what we know as the laws of thought. And these are laws, logical laws. Aristotle is known as the father of logic, mainly because Aristotle believed that logic had certain principles that were universal in arguments. That means that they are always there. They are universal. They stand the test of time. And Aristotle developed these laws of thought because he said that he noticed the patterns behind the arguments debated with Plato, which was Aristotle was the student of Plato. Plato was the student of Socrates. And I know we haven't talked too much about Socrates and Plato and Aristotle. Let's talk about Aristotle a little bit. We hadn't talked too much about Socrates and Plato. Just wait. Just wait. It's coming. The principles that the principles that Aristotle observed, he calls, again, the laws of thought. We have to remember that Aristotle is a mathematician at heart. That is what makes sense to him, seeing things in logical sequences. And essentially, again, when we think of patterns, When we think of algorithms, again, those are all based in math. And he believed just as in there are certain laws and boundaries in math, that these certain laws and boundaries have to be common in the world around us, and especially language. And so with Aristotle, these laws of thought are essentially combining the rules of math to human language. All right. So, with that being said, let's look at his three laws of thought. And these may sound, again, elementary. These may sound like, why do we even need to know that? But if we don't have a groundwork, if there's no foundation, you can't build upon it. So, let's take a look at, whoops, let's take a look at the first law of thought, which is known as the law of identity. The law of identity. It's a good movie back in 2000 and was it 2002, 2003? I want to say 2003. Uh, that don't sound right. Yeah, it is 2003. Called Identity, with John Cusack, Ray Liotta. Who else was in it? There was somebody else in it. No, it was a good movie though. Anyways, the law of identity. So the law of identity states that everything is the same as itself, or a statement. Uh, that should say cannot, or a statement cannot remain the same and change its truth value. Again, I'm making mistakes over here. All right, so let's explain this a little bit, especially since I screwed that up. Aristotle defined this law of identity as A is A. So A is not A, or A is A. A is not B. A is not C. And I think we're all very happy and lucky that A is not D or any other letter in the alphabet. A is A, and it is only A. A is specific. And that can be said about everything else. A tree is not a car. A tree is not a car. A tree is a tree. A tree is not a table, or a tree is not a table. A tree can be made into a table, but a tree is not in itself a table. A car is not a table. A car is not a tree. A car is a car. Uh, Again, I kind of went out of order right here, but again, a tree can become a tree, but it cannot do so without physically becoming a table. It then changes its identity, but it cannot be a tree and a table at the same time. Now, again, are there instances where this can be faulty reasoning? Well, there are other philosophers that come later that are going to talk about this, that while Aristotle is correct in many regards, there are some exceptions. This would be really brought further upon by a man named Bertrand Russell, a philosopher. He wrote a book called Problems with Philosophy, or Problems of Philosophy. And he talks about logic and the law of identity and really all the laws of thought in that book. I'm actually in the process of reading it. So I'll have a little bit more to tell you here in the next couple of days. I had to kind of not only refresh myself, but what's interesting about reading, especially philosophy books, is like the more you learn, the more that you see, or the more you know, the more you see. So the more you know about Aristotle, the more you can see in Bertrand Russell's arguments against Aristotle. Law number 2, looking at the law of non-contradiction. This is called the law of non-contradiction. It's also called the law of contradiction. So that's kind of contrary in of itself, which is odd. So, what the law of non-contradiction says is that nothing can both exist and not exist at the same time and in the same respect, or no statement is both true and false. Again, Aristotle defined this as A and not A. A is A, and A is also B is impossible. If A is A, then it is a truth, and it cannot also be false. So, let's look at this in terms of school. I've tried to give you guys some examples that you can understand a little bit more clearer. Aristotle breaks this down, what he sees to be the simplest of terms, but unless we can apply this, it becomes a bit more abstract, while it's a little bit more relative right here. So let's look at school. You cannot simultaneously be a sophomore and a junior. If somebody asks you what you are and you say, I'm a sophomore and a junior, well, either you have enough credits to be a junior and thus you are a junior, or you do not have enough credits and you are a sophomore. Now, could you be something other than those two? Yeah, you could. But again, you cannot be a sophomore and junior at the same time, the same way you cannot be a high school graduate and a non-high school graduate at the same time. You can be both things, but there is the limitation of time. And the law of non-contradiction says that it cannot be both at the same time. And we look at our examples right here. I'm going to move my face again. Do not enter and enter only. Like you can't do both at the same time. You cannot do both together. No pets allowed. All pets must be on leash. Well, if again, we see the contradictory nature of this law of thought in these oddly placed signs. All right, let's continue to our last law of thought, and that is the law of the excluded middle. So here's what Socrates stated with this: something either exists or do not exist, or does not exist, or every statement is either true or false. So Aristotle defined this as A or not A. A is either A or it is not A. So this is a little bit different, but it does go kind of hand in hand with the law of non-contradiction. So what the law of contradiction was saying is it cannot be both true and false at the same time. What the law of the excluded middle says is it has to be one or the other. So while the law of non-contradiction is talking about more so in a time-based area, the law of the excluded middle is talking about, well, take time out of it. It has to be one or the other. So let's look at weather. All right, so today, this is accurate, or at least it was accurate as of last night. Today they are calling for a high temperature of 82 degrees. So our statement, let's look at our statement right here. Our statement is today is going to be 82 degrees at its hottest. This statement can only be true or false. There is no middle ground. It cannot kinda reach 82 today. Either the statement is true and it reached 82 degrees, or it didn't, or it doesn't reach 82 degrees, and then the statement is false. It cannot be somewhat true or somewhat false. It has to be one or the other. So again, you can see the similarities between the law of excluded middle and the law of non-contradiction. They essentially, again, go hand in hand. You cannot have one without the other. It was actually these two that Aristotle kind of put most of his thought and effort into structuring and outlining, more so than the law of identity. The law of identity, we do see that there are changes that can be made. Again, a table can be, or excuse me, a tree can be made into a table, but there has to be a change of its value to change its identity. It cannot have the same value as a tree. A tree, gives off, oxygen, and the table does not. So they have different properties. And so that's what Aristotle is talking more so about, the law of identity. But the law of excluded middle and non-contradiction is simply about how there is no middle. There's nothing in between true and false. It's not halfway false, halfway true, and it cannot be both of them at the same time. It has to be, again, one or the other, which we refer back to in the law of excluded middle. Now, this may sound complicated. This may sound here's what I like about philosophy is that it's both extremely simplistic and it's both very complicated at the same time. That can be said about a lot of things. Said about anything, really. I mean, I think about baseball. Baseball is a simple game, but at the same time, there's so many complexities within it. And that goes for everything, whether it's playing an instrument, whether it is, competing in another sport, whether it is, whatever. You pick. You playing cornhole. Yeah, the game is simple, but, to actually, have the right arc, the right velocity, the right bounce, because you want to have a good board. Again, there's more complexities in it. The further you dive, the more complexities you see. And again, I think that can be attributed to about anything that we do. If you're into fashion, well, again, it may seem simple on the outside, like I understand what looks good and what doesn't, but then you learn more about designs and patterns and this and that, and then it's, again, more complex. So go ahead, and I want you to knock out the assignment. I know some of you already have. Knock out the assignment for today. All you're doing is just assigning the laws of thought to each statement so we can build upon this. We can look at some of the issues with this and take a little bit deeper dive into Aristotelian logic. Again, this is a class. This is an entire class. This unit is taught in colleges as an entire class. We are just kind of doing some introductions and just kind of touching the surface of what like logic really is in its essence. But we are going to be able to take something from this and apply it to our future units. But again, it's as complicated and you can dive as deep as you want to into it. So, we're going to keep diving. We're going to keep diving, but we're not going to have everything that we possibly need to decipher our future units. And that's just because, again, logic is a complicated tool. But hey, I appreciate you guys, and I look forward to. I'll be recording another video on Monday. Look forward to seeing you guys then. Again, tomorrow you will have just a quick quiz just to talk about some of the things that we've done this week. And hey, I appreciate you guys, and I'll see you tomorrow. Or, well, you'll see something from me tomorrow, and then you'll see me on Monday. There we go. Have a good weekend. Now, how do I pause this?